Okay, let's get started. Our first section is 7.1 angles and their measure. And the first video is going to be on topic one, which is an introduction to angles. Okay, so we have to build this idea of an angle first. Okay, when you're in a trigonometry class, you're dealing with angles and ratios of sides of right triangles or triangles. We kind of have to build that. We have to start from the bottom up, which is just what is an angle. Okay, so we have this definition first, and we've got several definitions here that we're going to cover. But the first definition we have is that of a ray. So a ray is a portion, it's a portion of a line that starts at a point V, which is going to be called something in just a moment. So a ray is a portion of a line that starts at a point V on the line and extends indefinitely in one direction. The starting point V we call the vertex, okay? So we have a ray and a vertex, and we have a little image down here that kind of shows what's going on, okay? So we have a line, and in case you're unfamiliar, the formal definition of a line is you extend in opposite directions indefinitely. There's no endpoints. You just go forever and ever and ever in opposite directions, okay? Well, a ray has this starting point called the vertex right here, and then you extend in just one of those directions forever and ever and ever. So if we kind of cut out this ray just off on its own, you have a starting point, you extend in one direction forever. Okay, that's a ray. And this little point, the end point, is called the vertex. Okay. Now, what's really cool about this is if you have a single vertex that has two rays coming out of it, you have formed an angle. So if we have another ray coming out of this very same vertex, we have created an angle. Okay, so think of this as like ray one, which will have an official name in just a moment. This is ray two, and then you have your vertex. Okay, so let me plug my computer in. It's about to die. There we go. Okay, so if we have, like I said, two rays coming out of a single vertex, it's called an angle. Now let's talk about what those two rays are officially called. Up here in this image that I drew, we just called them ray one and ray two. That's not very fun. Let's give them official names. So one of the rays is called the initial side. The second ray is called the terminal side. So let's go ahead and officially name these. So we'll erase ray one and ray two. Let's say this is our initial side. And then this is our terminal side. Oops, I'm going off the page. All right, so we have initial side, and then we have terminal side, okay? And basically what's happening, and I do have this weird glove on so I don't get smears all over my tablet because it makes me feel icky, but basically if you have your initial side and your terminal side laying one on top of the other, you take that terminal side and you start to sweep it out, and that creates your angle. And how far we sweep out the terminal side from the initial side is how we measure angles. So we do measure the size of angles. That'll be another video, but that's how you would measure them. So initial side and terminal side, they're one on top of the other, and then we sweep open in one direction. Okay. Now, the direction that you open or that you sweep open does matter. Okay. So that leads us to our next definitions. So next up, we have if the rotation to form the angle is drawn in a counterclockwise direction, the angle is positive. So let's think about what that means. So we're going to draw a positive angle over here. I do feel like a sneeze is coming, so if I sneeze, deepest apologies, okay? So to draw a positive angle, you start with your vertex and your initial side, so that first ray. So we've got our vertex, we've got our initial side, and then we want to sweep open the terminal side in a counterclockwise direction. So that means we would sweep open this way. And then when we draw that terminal side, we have created a positive angle, okay? Now, if we open in the clockwise direction, that creates a negative angle. So the direction that you sweep open your angle really does truly matter, okay? So let's draw a negative angle. So you have your vertex, you have your initial side, so that first ray, and then if we were to sweep open in a clockwise direction, we create a negative angle, okay? So you have your initial side, you have your terminal side kind of laying on top of each other. If you sweep counterclockwise, that becomes a positive angle. If you sweep clockwise, that becomes a negative angle, okay? And that leads us to this next idea of standard position, okay? Whoops, I went too far. All right, so next up we have this idea of standard position, okay? So an angle is in standard position if the vertex is at the origin and the initial side is along the positive x-axis. Well, what in the world do we mean by that, okay? So let's come back up here and I'm going to show you. So I'm going to erase this ray right here really quick so that I have some more room. When we're talking about the origin and we're talking about the positive x-axis, we're talking about the Cartesian plane. Some people will call it the rectangular coordinate plane or the rectangular coordinate system. Some people just call it the xy plane. But basically, it's that two-dimensional space that we graph on. And if you have completed 171, which all of you should have, you should know what this is, okay? So we have our x-axis, we have our y-axis. We know these two number lines intersect at the origin, which is right here. So that's the origin. And then when you're looking at the x-axis, to the right of the origin is the positive x-axis. To the left is the negative x-axis. Above the origin is the positive y-axis. Below the origin is the negative. I think I said positive, it should be the positive y-axis. I may have said x. And then below the origin is the negative y-axis. So if we look at that definition for standard position, they're saying, hey, if you were to draw an angle in standard position, you're drawing it in this Cartesian plane, okay? So what that would look like is we draw our little Cartesian plane right here. And I'm going to draw the angle in red so it's really easy to see. But you would have your vertex at the origin, and then the initial side is on the positive x-axis. That's what they mean. That's the standard position. You start here, and then you sweep out your angle counterclockwise for positive, clockwise for negative. So if we were to sweep it out like this, we have a positive angle. Okay, so that's what they're talking about with standard position. Just know when they say origin and positive x-axis, it means exactly what you would think, just that regular Cartesian plane that we're used to graphing functions in. Now, next up, I do have a little note here that we typically denote angles with Greek letters. So you will be introduced to several Greek letters in this section, or not this section, but this chapter. You'll see alpha, beta for sure, theta for sure, omega, and maybe phi in chapter 7. So you're going to see several Greek letters, so be on the lookout for those. All right, our first example just says draw each angle in standard position, label the initial side, the terminal side, the direction, and the vertex. I've left this open-ended. We technically don't know how to measure angles, so we're just going to draw generic positive, generic negative, okay? So let's see, for our first positive angle, we want our vertex to be at the origin. We want the initial side to be on the positive x-axis. And for this to be a positive angle, we have to open in the counterclockwise direction. And we're told to make sure we label the actual direction. So we just put that little part of a spiral with an arrow, and that tells the reader which direction you're opening this angle, okay? So we have our initial side, our vertex, we already drew our direction, and then we have our terminal side. That's a positive angle, okay? Now, what if we had a positive angle? So vertex, initial side, whoops. I hate when Microsoft does that. It tries to like draw like perfect lines and stuff. It makes me crazy. I don't need it to be so perfect. Okay. So what if we start our revolution and we go around, 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 and we do one full revolution plus some? Well, that's totally okay. You can do more than one revolution. You could do 10 revolutions. It's still a positive angle as long as you're going in the counterclockwise direction. So we draw our angle. We want to make sure we put our direction, and then we label. This was our initial side. This was our terminal side. This was our vertex. Okay, so those are two standard position positive angles with the correct labels. Let's do our negative angles in blue. So for part C, we have a negative angle that we need to draw. So we're going to draw our vertex and our initial side. And then we want to start to sweep open in the clockwise direction. So I could start sweeping open. Let's say we like it right here. And there you have a negative angle. So we have our initial side, our terminal side. We already drew the direction, and starting that spiral and putting an arrow is really important. And then we have our vertex. Okay, let's do one more negative angle. So we have our vertex, we have our initial side, and let's say we sweep around, sweep around, sweep around, sweep around, and we decide to stop here. So we've drawn the direction already. We have our initial side, our terminal side, and our vertex. I'm gonna have to squeeze it out there. And what I do want to draw your attention to is angle B and D. This is why it's important to draw the direction, because if you're just looking at like the angle part, B and D look like they could be the same angle, but they are definitely not the same angle. We have a positive angle versus a negative angle. The size of the angle is quite different. But what I will tell you is in a later section, we're going to talk about things called coterminal angles, and they are angles that have the same terminal side. So these two angles look like they could potentially have the same terminal side, and we'll learn what that means. But just understand that though these look the same, they're very, very different. So drawing that like little directional spiral is really, really important. Okay, so that's it for topic one. Make sure you kind of understand these definitions, like what is an angle, first of all, initial side, terminal side, how to get a positive, how to get a negative, and what is standard position. And make sure you know how to draw a basic angle. Okay?